So Lorentz force was given by Lorentz force F is equal to Q into E plus V cross B. Right. Now see here we have two forces, right? Magnetic and electric force. Now magnetic force was what? Fm is equal to Q into V cross B. Now the cross product is a sign product, correct? So we have Fm is equal to Q VB sine theta into n cap, correct? See here, one very important thing is whenever we do cross product, not only magnitude, direction also plays an important part, right? So to figure out the direction, so like before in vectors what we were studying, the direction is determined by right hand screw rule, right? So if you look at this, see we have XYZ plane, the charge is placed here, right? Now if you look at this, the velocity is in y-axis, the magnetic field is in z-axis, so the force will come in the x-axis. See how we got this is by the right hand screw rule. Okay, so wherever, so if you stretch your right hand, let's say this is the direction of B and this is the direction of B. If you rotate your right hand, the direction of the thumb gives the direction of the cross product. Okay, so this is how we got the direction. Now, so we understood the magnitude, which is dqv sine theta into n cap. We understood the direction, that's because of the cross product right hand screw rule. Now what we'll do is, see, suppose in case if Fm is 0, that means the angle between V and B has to be 0, correct? Like see in this case we have charge Q, this is the velocity, this is the magnetic field. What is the angle between these two? 0 degree, right? What is sine 0? 0. So Fm becomes 0, right? So this is one of the cases. The second case is if the object is stationary. If the object is stationary, what is the velocity? 0. See like this is the object at rest, but it has its own electric field, correct? Right. So what will be the force? F is equal to Q into E, right? What do you get from this? What do you infer? Go back to first chapter. F is equal to QE. This is nothing but electrostatics, right? Which is nothing but charges at rest. So from Lorentz force we can actually get electrostatics concepts. Okay, this plays a very important relation between charges at rest and charges at motion. Alright. Okay, so now we learned about when it is 0, right? Now what if theta becomes 90 degree? Then force is maximum, right? So if you look at this, see this is a charge. So what we have is we have the velocity and force. They're perpendicular to each other, correct? So if they're perpendicular, then obviously dqv sine 90, so it will be just dqv, right? So we learnt about force, we learnt about when it is 0, when it is maximum, minimum, all these cases. Now any physical quantity, SI unit. So let's go to the unit. So we have unit of magnetic field. Now we derive the unit of magnetic field using force. So what we have, F is equal to dqv sine theta. Now sine theta has no unit, it's a dimensionless quantity, right? So we have B is equal to F by QV, correct? The unit of F, Q, V are known, right? Which is Newton by Coulomb into meter per second, right? This is what we call as Tesla. Okay, so Newton per Coulomb into meter per second, that is basically Tesla. So if we say 1 Tesla is equal to 1 Newton per 1 Coulomb into 1 meter square. In other words, if 1 Tesla is the magnetic field, that means the charge has 1 Coulomb, it's moving with a velocity of 1 meter per second, and the force exerted on the charge or by the charge is 1 Newton. Alright, so here 1 Tesla is actually a very big quantity. Okay, it's very big quantity. So practical unit is Gauss. Alright, so 1 Gauss is 10 to the power of minus 4 Tesla. Alright, now why we use Tesla? Tesla is in order to in order to honor the scientist Nikola Tesla, because he has done a lot for this magnetism and electricity field. So because of that, we have named the SI unit of magnetic field as Tesla. Alright. See, I told that Tesla is a huge quantity, right? To give a comparison how big Tesla is, see, Earth's magnetic field. Earth has a magnetic field. Right? Earth's magnetic field looks something like this. Earth's magnetic field is very less. It's 36 micro Tesla. See, it is 36 into 10 to the power of minus 6 Tesla. Now I think you are able to imagine how big 1 Tesla is. Right? Earth, which is so big, that itself has 36 micro Tesla. See, practically we get 1 Tesla, like some of the magnets, like neodymium magnets have 1.2 Tesla magnetic field. Alright, as for research purposes, we do different. For medicinal purposes mainly, MRI machine uses around 3 to 5 Tesla magnetic field. That's very huge. Okay, so medicinal purposes, we use around 3 to 5 Tesla. For more research purposes and all those things, we have a magnetic field of around 30 Tesla. 30 Tesla is huge, tremendous, because no camera will withstand 30 Tesla. Nothing. Alright, but obviously these are all man-made things. Always nature proves that she's our mother, because the highest magnetic field is a star called Magneta. It has a magnetic field of 10 to the power of 10 to 10 power 11 Tesla. See, that's like insanely high. See, just to give a relation, or just to give an information as to how big that is, suppose let's say a magneta is around the distance of moon, which is around 3.5 lakh kilometers from Earth. If we have a magnetar at that distance, that magnetar will rip apart atom by atom, because electrons are basically magnetic, small magnets, they are revolving. So that magnetar has the power to rip apart a proton and an electron. Even though it's very fascinating, but it's very, very deadly. Alright, so this is how magnetic fields are. So, see, it's not about that. Our human body also has a magnetic field. Our human body has a magnetic field of about 10 power minus 10 Tesla, which is very, very less. Okay, so like this, whatever we see, almost everything has very minute magnetic field. Even interstellar space also has magnetic field. That's even lesser. It's around 10 to the power of minus 12 Tesla. So like this, magnetic field can vary from small atom to the biggest of biggest stars. Okay, so the magnetic field, whenever we are defining magnetic field, we usually use Gauss, because that's more of a practical unit, but SI unit is Tesla. Alright, so but we define the SI unit of magnetic field using Lorentz force.